Today we're just going to look at two quick problems that are going to look exceptionally similar to each other. I forgot to throw this type of indeterminate limit in when we were talking about the methods of dealing with indeterminate limits last time. So this is just going to be another u-substitution style one. But I think it's important that you see a couple of these because I have seen them pop up on the AP test. So whenever you see something like a limit as x approaches, let's say 1, x to the some fractional power minus 1 over just x minus 1, or the reciprocal of that, you're going to want to use a u-substitution. And obviously, if you plug 1 into both the numerator and the denominator of this, you get 0 over 0, right? 1 to the 1/8 is 1. So 1 minus 1 in the top is 0, and then the denominator 1 minus 1 is 0. So we get an indeterminate limit. So we're going to just let u equal x to the 1/8. And if u is equal to x to the 1/8, then we should be able to see that x is equal to u to the 8th, right? If we raise both of those just above wherever on x equals u to the 8th, if we raise both those things to the power of 8, u to the 8th and x to the 1/8 to the 8th, we end up with x equals u to the 8th. And as x approaches 1, that means u is also going to approach 1 because, well, if x is approaching 1, right, 1 to the 1/8 is still 1, so u must also be approaching 1. So this can just straight up turn into a limit as u approaches 1 of, well, x to the 1/8 is just u, so u minus 1 over u to the 8th minus 1. And if you've done it correctly, you should still end up with an indeterminate limit, right? This is still just 0 over 0. So we'll go about factoring this. So we'll say a limit as u approaches 1 of u minus 1 over, well, u to the 8th minus 1 is just a difference of squares. It's u to the 4th plus 1 times u to the 4th minus 1. And again, I have nothing to cancel yet, but we'll just take one more step down here. It's a limit as u approaches 1 of u minus 1 over, well, u to the 4th plus 1 doesn't factor in a way that's useful to us here. But u to the 4th minus 1 does. That's u squared plus 1 and u squared minus 1, which I hope you see where this is going now. I'm just going to keep breaking these down until I end up with the u minus 1 term that I need in the denominator. So I've got u to the 4th plus 1, u to the 2nd plus 1, and my u squared minus 1 will just become u plus 1 times u minus 1. Now that I have u minus 1 in both the numerator and the denominator, I can cancel it out as long as u isn't 1, which it's not. It's approaching 1. And we're just left with a new limit. The limit is u approaches 1 of 1 over u to the 4th plus 1 times u squared plus 1 times u plus 1, which is just 1 over, well, u to the 4th. 1 to the 4th is just 1, so 1 plus 1 is 2. Same here, u squared plus 1 when u is 1, that's just 2. And then u plus 1 is also just 2 when u is 1. And we end up with the limit equal to 1 over 8. Hopefully not too bad. And we'll just look at one other one. You could probably guess what our method's going to be here. We'll note that this is indeterminate. This is 0 over 0. And we'll let u equal x to the 1/5, since our fraction is 1/5 this time for our power, which tells us that x must be equal to u to the 5th. And then, well, from there, we'll just say as x approaches 1, u must also be approaching 1, right? Because if x is going to 1, what is u? What happens to u? Well, it becomes 1 to the 1/5, which is still just 1. So we've now got a limit as u approaches 1 of, well, x to the 1/5 is just u, so we've got u minus 1 over x minus 1, where x is u to the 5th, so u to the 5th minus 1. Which again, if you've done this correctly, you should still be getting 0 over 0, which we do. So that means we need to factor. And we talked about sort of just in our heads knowing previously that we should be able to come up with what that factor in that denominator should be. We know it should divide by u minus 1. evenly because we need to get the u minus 1 in the numerator to cancel with the u minus 1 in the denominator to solve this problem of being indeterminate. So we could go through and say what are all the possible rational roots of this using the rational root theorem, and then test them all using synthetic division. Not that there's a lot of them, there's really just 1 and negative 1. But we know that positive 1 needs to work, right? We need to have a factor of u minus 1. So we can just put the 1 up in our box for synthetic division, and then we can list our coefficients going out to the right. We have 1 u to the 5th, 0 u to the 4th, 0 u to the 3rd, 0 u to the 2nd, 0 u, and a minus 1 at the end. And so if we do synthetic division with this, this will be like dividing u to the 5th minus 1 by u minus 1, right? U to the 5th, 4th, 3rd, 2nd, 1st for the zeros going across there. This is u to the 5th power here with the 1, the 4th, the 3rd, the 2nd, the 1st power, and then down to our constant term. Okay, so let's go through and do our synthetic division. If you don't remember how to do synthetic division, you really need to refresh your memory on that. I'll kind of talk us through it sort of slowly here, but you should be able to do it quickly enough. First step in synthetic division is drop that first coefficient below the line. Then anytime you have something that's below the line, right, at 1, we're just going to multiply it by what's up here in the box, by this 1. So 1 times 1 is 1. Then anytime we have something that is two numbers above the line, we're just going to add them together and put it below the line. So 0 and 1 is 1. Now I have a number below, multiply it by what's in the box and put it in the next column. 1 times 1 is 1. 0 plus 1, 1. 1 times the 1 in the box is 1. 0 plus 1 is 1. 1 times the 1 in the box is 1. 0 plus 1 is 1. 1 times the 1 in the box is 1. And negative 1 plus 1 is 0, which is exactly what we want to happen. If it doesn't come out to be a 0 at the end, it means that that thing doesn't actually evenly divide. So we know that u to the 5th minus 1 did divide evenly by u minus 1. It came out to be, so we'll write it out here, this is now a limit as u approaches 1 of u minus 1 over u minus 1 times, when we write this out, these numbers down here are just our coefficients in front of each power, and we always drop from our starting power. It was u to the 5th to begin with, so now since we factored out a u to the 1st, that should drop to u to the 4th. So it's 1 u to the 4th, 1 u cubed, 1 u squared, 1 u, and 1. Right? And now we can cancel the u minus 1s, unless u is 1, but we know u is not 1. U is approaching 1, so those will cancel. So we end up with a limit as u approaches 1 of 1 over u to the 4th plus u to the 3rd plus u to the 2nd plus u plus 1. Well, if I plug 1 into each of those, u to the 4th, u to the 3rd, u to the 2nd, and u, they're all just 1. So this is 1 over 1 plus 1 plus 1 plus 1 plus 1, or just 1/5. So this is one extra style of u-substitution that you might see pop up on the AP test or on one of my tests, right? Problems where it's like x to some fractional power minus 1 over x minus 1, or the reciprocal of that. So just one more good one to be familiar with that I forgot to do last time. So that's it for today.